this video, we are going to discuss some numericals. Numerical number 1. The sun is at heart. The sun is at hot plasma. Hot plasma. Hot plasma. Once again, I am repeating the point. The sun is at a hot plasma with its inner core at a temperature exceeding 10 to the power of 7 K and its outer surface at a temperature of about 6000 Kelvin. At such high temperature, high temperatures no substance remains in a solid or liquid pressure or liquid phase. In what range? In what range do you expect? The mass density? The mass density of the sun to be question mark if the range of range. If the range of densities of solid comma liquid comma gases, question mark. Check if your guess is, if your guess is correct from the following data, the following data. Once again, my dear students, up to here I would like to repeat the question. Please observe carefully. The sun is at a hot plasma with its inner core at a temperature exceeding 10 to the power of 7 Kelvin and its outer surface at a temperature of about 6000 Kelvin. At such high temperatures, no substance remains in a solid or liquid phase. In what range do you expect the mass density of the sun to be? Question mark. If the range of densities of solid, liquid, gases. Check if your guess is correct from the following data. Now I am writing the data. Mass of sun is equal to 2.0 into 10 to the power of 30 kg. Radius of the sun is equal 7.0 into 10 to the power of 8 meters. My dear students, these are the data given by the examiner. Even though he not given the data, we have to remember in the first some videos I already told the radius of the sun, the mass of the sun, mass of the earth, radius of the earth, everything I already explained. Now go for solution. Now go for solution. Given mass of the sun is equal to 2.0 into 10 to the power of 30 kg. Radius of sun is equal to 7.0 into 10 to the power of 8 meters. Next, density is equal to how much? Now, formula density is equal to, my dear, remember how we can write it as? Please observe carefully. This is we can call as rho, called as density symbol. Okay, now Another symbol also there, D. This is also density symbol. Please remember, these two we will use frequently in the videos or in the physics. So rho is equal mass by volume, that is equal m by 4 by 3 pi r cube, that is equal 3 capital M whole by 4 pi r cube, that is equal 3 into 2.0 into 10 to the power of 30 whole by 4 into 3.14 into 7 into 10 to the power of 8 whole cube, that is equal 1.392 into 10 cube. What is the unit? kg by meter cube. Okay? Now, concept about this one. This is the order of density of solids and liquids. Solids and liquids and not gases, The high density of sun is due to inverse gravitational attraction. On outer layers due to the inner layers of the sun. Once again, I am repeating this concept. This is the order of density of solids and liquids and not gases. The high density of sun is due to inverse gravitational attraction on outer layers due to the inner layers of the sun. Now, numerical number 2. Numerical number 2. When the planet the planet Jupiter, when the planet Jupiter is at a distance of 8 to 4.7 million kilometers from the earth. Its angular diameter is measured to be 35.72 seconds of arc. Calculate the diameter of Jupiter. Question mark. Now, once again I am repeating the question, my dear students. When the planet Jupiter is at a distance of 824.7 million kilometers from the earth, its angular diameter is measured to be 35.7 to 11 of arc. Calculate the diameter of Jupiter. This is the question. Now, solution. Given R is equal to 824.7 into 10 to the power of 6 kilometers. Now, theta is equal to 35.72 seconds. That is equal to 35.72 whole by 60 into 60 into pi by 180 radians. 180 radians. Now, diameter L is equal to how much? My dear students, this is the data given by the examiner. This is also given by the examiner. This is we have to find. Now, go for the solution. We know that R is equal to L by theta. That implies L is equal to R by theta. L is equal to R into theta. L is equal to R into theta. Consider it is equation number 1. Therefore, L is equal to 824.7 into 10 to the power of 6 into 35.72 whole by 60 into 60 into pi by 180. That is equal to how much? 1.429 into 10 to the power of 5 kilometers. So, Like that, we have to solve any type of the numerical. However, thank you very much for watching this video. Thank you.